In this presentation, we will delve into the fascinating world of Boolean algebra, focusing specifically on algebraic simplification. Boolean algebra is a branch of algebra that deals with logical operations and binary variables. Here, we will explore how to simplify complex Boolean expressions using various algebraic laws and theorems, making them easier to understand and implement in digital circuits and logic designs. Let's start by exploring the fundamental laws and identities that form the backbone of Boolean algebra. First, we have the identity law, which states that a plus 0 equals a, and a multiplied by 1 equals a. Next is the null law, where a plus 1 equals 1, and a multiplied by 0 equals 0. Then there's the idempotent law, which tells us that a plus a equals a, and a multiplied by a equals a. We also have the complement law, stating that a plus a prime equals 1, and a multiplied by a prime equals 0. Lastly, the involution law shows that the complement of a prime, or a prime equals a. Now let's examine the commutative and associative laws, which are crucial for rearranging and grouping terms in Boolean expressions. The commutative law allows us to change the order of variables without affecting the result. It states that a plus b is equal to b plus a, and a multiplied by b is equal to b multiplied by a. The associative law, on the other hand, allows us to group variables differently. It states that a plus b, all added to c, is equal to a plus b plus c, and a multiplied by b, all multiplied by c, is equal to a multiplied by b multiplied by c. In this section, we will explore the distributive and De Morgan's laws, which are essential for expanding and simplifying Boolean expressions. The distributive law allows us to distribute a variable across terms. It states that a multiplied by the quantity b plus c equals a multiplied by b plus a multiplied by c. It also states that a plus the quantity b multiplied by c equals the quantity a plus b multiplied by the quantity a plus c. De Morgan's law provides a way to simplify the complement of expressions. It states that the complement of a plus b is equal to a prime multiplied by b prime, and the complement of a multiplied by b is equal to a prime plus b prime. Let's walk through a practical example of simplifying a Boolean expression using the laws we've discussed. Consider the expression a multiplied by b plus a multiplied by b prime plus a prime multiplied by b. First, we factor out a from the first two terms, resulting in a multiplied by the quantity b plus b prime, plus a prime multiplied by b. Since b plus b prime equals 1, the expression simplifies to a multiplied by 1 plus a prime multiplied by b. Finally, since a multiplied by 1 equals a, the simplified expression is a plus a prime multiplied by b. Here, we will explore the absorption theorem, which provides key simplification rules for Boolean expressions. The absorption theorem includes the rules a plus a multiplied by b equals a, and a multiplied by the quantity a plus b equals a. Additionally, a plus a prime multiplied by b equals a plus b, and a multiplied by the quantity a prime plus b equals a multiplied by b. These rules can significantly reduce the complexity of Boolean expressions. Let's work through another example to demonstrate the application of Boolean algebra laws in simplifying expressions. Consider the expression the quantity a plus b, multiplied by the quantity a plus b prime, multiplied by the quantity a prime plus c. First, we expand the first two terms. This results in a plus b multiplied by b prime, multiplied by the quantity a prime plus c. Since b multiplied by b prime equals 0, the expression simplifies to a multiplied by the quantity a prime plus c. Applying the rule a multiplied by the quantity a prime plus c equals a multiplied by c, we get the simplified expression a multiplied by c. Here is a suggested strategy that you can use to approach simplification problems. Start by looking for common factors and applying the distributive law. Next, apply complement laws such as a plus a prime equals 1 and a multiplied by a prime equals 0 to simplify terms. Then, use absorption theorems to eliminate redundant terms. Finally, apply De Morgan's laws when dealing with complements to further simplify the expression. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.